Like in decomposition.
Yes.
Yes. Checkerboard. And you finish this?
Yeah.
All of you?
Yeah.
Do I need to talk about it? Okay, cool. That's great. You all finished it. And you follow this, or you come up with your own solution?
Yeah, I did that.
Yeah.
But I didn't read it, but I didn't see it.
So,
You use alternate lines.
so this is a hint.
I made like 2 lines and then did 2 lines.
So the idea I introduced here is that for checkerboard, Karel, you basically use alternate line to lay your beeper on the bottom line, and then come back, go up, go step forward, and then lay another line, and then come back and come up and lay a third line. Is the solution you guys used?
Yes.
Okay. So let's. But anyway, let me go through this. How do we work this way? So remember, this is the checkerboard we composed last time, and it's basically put down an alternative line. And let's draw that.
No, I did it so it works.
And in this word, you can see that it actually lay a alternate line on the bottom, and so we can actually rename this as alternate line, and then make this private. And then we have another private public void run, and then we can have so we put down alternative line first. This will actually, I spelled it wrong. And then we go up, go back. How do we go back? Suggestions?
But isn't it already? Oh wait, no. Just
Why don't you just turn around, go back?
to a wall.
Yeah.
Proceed until blocked.
That's what I read. See, it's like right here. But for some reason, my turnaround wasn't working. I just turned right both times.
Okay.
Seriously.
And?
Why wasn't it?
What should I do next? What should I do next?
When you move to wall,
You have to
turn right. Make sure front is clear. Move. Move and then turn right again.
Just a second. So you're saying that move and
Turn right.
and
And then exit the loop.
where's the loop?
The if loop.
Yeah.
Oh, this is not called a loop. This is a branch.
Okay.
And
then you move forward. And then
turn right.
And then you do alternate line. And then you turn around.
Move to wall. Here. Turn right. And then
Wait, no. If
you don't have to
turn left.
Right.
Because you're this way now, right?
Where's that? No, it's the same. Isn't it just another line of the same thing?
Oh yeah. Oops. Sorry.
Turn right if front is clear. Move. That's what I think. It's funny.
And then turn right. And then move.
She's at the outside of the bridge.
It doesn't matter.
And where do I?
That's it, right?
And then, yeah. And then alternate. Oh wait, no, it's okay.
So we can't go along with this, right?
Yeah, you have to do while front is clear.
So where do I put the while?
I did
After alternate line.
Well, actually, I made like another. I made this a private void and gave it a name called 2 lines, and then created another one called public void, and then just put this. Yeah.
Cool. So basically, you made a private void.
And then named it 2 lines because it is
2 lines.
Yeah.
2 lines. And because you realize 2 lines is a pretty good pattern. And then basically every 2 lines is repeat the same pattern. That's a cool way to think about it. And so this is 2 lines. And what it does is that this is one alternative line. Go back and then see if up is you have 1 line above you, go up 1 line and then do another line. And then go back and move forward. And do you need? Is this the 2 lines you're talking about?
Yeah.
All these?
All of that together. Right?
Okay, let's try this. So basically, there's another optimization we can do here. So you see that we have alternative line, turn around, move toward. Alternative line, turn around, move toward, turn right. Seems that we always repeat these things. So another way we can do this is that we can actually move these. Move this here. So here we basically change his path post position. So here the precondition is that we start from the left of the line facing east, and the post condition, however, is we go back to the first. So basically, we go back to the
Really?
west wall, facing north.
Oh.
Okay.
See, actually here we
Oh right.
turn
right.
around, move to one, and then turn right. So we're facing north. And now we have alternative line, and then we know that after alternative line we're facing north. So when we judge that front is clear, we move up and then turn right. Okay, let's see whether this works. And then we still need a public route. So what should I do here?
Just wall front is cleared 2 lines.
Front is clear.
That's like basically what happened to me.
That's it?
I'm not sure if it'll work or
think
not
so.
anymore, so.
But
Can you actually examine the problem? I already see some problem with it.
Is it because it's 2 lines at a time? So if it's a
Yeah, good thinking. Keep talking.
if it's an odd thing, because it's 2 lines at a time, it's gonna block, and then Karel's gonna have a bug on his face.
Yes. So let's try that. Let's try to see whether that's a.
When it works.
You have a hypothesis and you're trying to try. So this is a 8x8, and it won't show you a problem. So let's load another program.
You can just edit world and draw a line on top.
Yeah, that works too. But anyway, so let's try 7 by 7. And we already have this and start program. It actually looks pretty good, other than the fact that it tries to go up. And so as you predicted, we have a problem. How to fix it? Hinako, you haven't speak yet.
How about you put a wait.
How about you put a
Do you know which line it actually has the problem? Where it makes the problem?
this one?
Yes. Yes, exactly here. Here is a problem. When you move, you find that it actually.
So the move has to be inside the branch. The branch.
That's it? I feel like that was more.
We can actually verify this hypothesis. You have a hypothesis, and you want to test whether the hypothesis is true. So in here, the hypothesis is that the problem happens here. Is that true? So we put the break line here. We put a break here. And then we go debug it. And of course, first we need to load a word with odd number of lines, and then we start. So this is actually the first time we hit the breakpoint, and then we can let it continue to run to see what the next time it hits the breakpoint. Okay, next time it hits breakpoint here, and keep going. And try to see when it hits the problem.
And then it has move, but like it can't move, so move has to be inside the loop.
Yes, you're absolutely correct. The problem happens here, so you cannot move because the front is blocked. So what's the solution? Move has to be inside the branch. Does it work now?
I think so. Yes.
Let's try it.
I know what's wrong with
Is there is another problem.
Oh,
Can you guess?
Okay. See, I got that part right.
Okay, if you cannot see it, let's run.
Oh no.
This is actually part of the fun. You like playing a mind game, and you guess what will happen and see for yourself. So we load an odd number of lines, and then we start the program. Wait for it.
Oh, what?
But you never specified where Karel had to go, right?
Yeah, that's true.
So it's right!
You're never gonna
You
learn
can
this
just
right if you're just like,
turn
oh,
north
Karel
and
ran into a wall way down there. But it wasn't specified, so it doesn't really matter.
So yeah, that's a mystery. So what happens when you actually move here and then you do another alternative line? So when you are here, you try to go up, you cannot. This is actually very unexpected. So let's see what actually happens here. So we run it again using odd number of lines, and then we start the program. Then we wait until So it reaches here, and then it tries to lay another alternative line.
But front isn't clear.
So let's go inside the inside the function, and then we say put beeper. That's a problem right there. You are actually putting two beeper in the same position.
But it didn't show.
It didn't show.
It didn't show for some reason, and then something is wrong. While the front is clear, well, the front is not clear, so we
turn around and then you move to wall.
Move to wall. It did show here is 2.
Oh, I think it's because we're so far away we can't see.
Yes, you shouldn't sit so far away. See?
Wait, there is a 2.
There is a 2
I feel like it was
here.
there before, but.
Okay, so that's a problem right there, and you turn right. And let's continue this and see what's going on. You turn around and then you see front is not clear, so you don't do anything. And then now front is not clear, you go out, and then you finish.
I know what you can do. At the end, put like turn and then check, and if there's another beeper, pick up the beeper and go back. And
Wait,
not,
where? Here?
Well, this is like a really like easy way out, but at the end you can just.
At the end, which end?
At the end of like run.
At the end of the run.
Yeah.
And then you go back up and then pick that up.
Yeah. And be like, if the beeper is there, then pick it
but
up.
for an alternate line, can't you just add right before put beeper if no beeper's present?
Okay. Any other solutions?
Oh yeah, you can just put if no beeper's present and don't do the thing that caused the problem.
So there's another way to think about it. Actually, what you said might work. There was a difficulty here in run back and check because in Karel it's kind of hard to judge whether that place has 2 beepers.
We should fix that.
So that's kind of hard, but what Sophia said might work is actually you go back and patch things. But you can think of another way. Remember that before we make any changes, this was actually here, right? So you're saying that this alternative line, when you put down here, and then you find that you shouldn't move, so you move it here. In the case you shouldn't move, should you actually put down another alternative line?
No.
No. So in this case, you should probably move them here in the case that you either, if you can move up, you can put another alternative line. But if you cannot move up, which means here, if you cannot move up, which means that you're at the top already. And in this case, what do you do?
If you're already at top?
So basically, if this is false, meaning that, where are you? You're at the top of the line. So when you're at the top of the line, what do you do?
You stop.
You don't do anything. So basically, everything is in here.
Okay, I have a question. Do you have to make this program work for a world that is one space wide? Because it isn't possible.
How do you make a checkerboard on the world that's one space one?
You have one and an empty one.
That is a very good question. So for alternative line, that is difficult. And that's a very good thinking of that. When you program, you think about all kind of different corner cases.
You can just put at the
In
front,
this case, yes, it's actually a pretty good thinking. Okay, so let's stop this and wait. We made the changes. Now let's run again to see whether our changes works. So we load a program word with 7 by 7, and then we start a program.
Oh no.
No, it's in debug mode.
Oh, it's in debug mode, so basically it's actually in here. So we remove this.
Then you have to exit out and then
We can actually press this, resume.
Oh,
Okay, I know it was a resume.
It worked. So basically, the key here is that if you know you're already at the top of the line, you don't do anything. Okay? And you can actually even put all these after here. It's the same idea. So let's see whether that will work. And let's test this first. Start program.
Yay!
It works. And then we tested on a odd number of line works. And then start program.
Test it on a 1 by 1
1 by 8.
Yes, we'll see.
1 by 1?
They have 1 by 8.
Oh.
And so
Clear. And
So,
Carol just stand there. What do I do?
Wait, if you did it on a 1 by 8, it's supposed to look like a straight line, or like
No, it's a
dot.
box. See, it's like
Yeah, you know. So it's supposed to be like all of them are filled with papers.
it doesn't run at all.
yeah, because front isn't clear, so
Oh.
Carol just stands there and won't listen to anything else.
So,
So
if front is not clear, turn left.
actually, Sophia, that's a very good thinking. So basically, the
Oh, you could do. Yeah, what you said. If front is not clear, turn left and do alternate line. It works.
Yeah.
for the simplicity of this program, we don't think about it just now. So this is actually a very good thinking that you identify a corner case that things doesn't work.
What about 8 by 1? It just does alternate lines.
Yeah.
Yeah, one line will work. Let's try that. So basically, we can load. We can create a new word, and then that is 10 by 1. Okay, and then we can say 10 by 1 dot w, and then we say word, and then we start program. It works. It works for this way. It doesn't work for vertical ones. We'll come back if we have time for this and think about it, how to solve that corner case. You will find later in your programmer's life that most of the cases you just deal with all kinds of corner cases that makes your meticulously crafted program fail. That's what you will spend most of your time on. Okay, so let's go to the next assignment, middle point. So remember what the middle point is about?
It's about
The
trying
hit made it super easy.
So basically, you're trying to find the middle point of the bottom line and let the let Karel stay there. So in the case that you have even number of cells in this world, you want Karel to stay in either 4 or 5 position. In the case that you have a world with odd number of cells in the bottom line, you want it to stay at the middle, right at the middle, in this case 3. So that's a requirement. And I did actually put the hint here, since this is pretty hard. So this is the solution we actually like. And it's basically 3 steps.
It's supposed to be in 4 and 5.
This is not a complete solution, because the complete solution is that there is, so this is 9, so which means that at the end, the Karel should stay at position 5, and there shouldn't be any beepers under it. So this is
Wait,
just.
Does Karel have to be facing a certain way?
No, it doesn't say.
Okay.
So that's a requirement if you remember correctly. So are your solution like that?
Mine is slightly different. I have 2 here, and then I move them closer, and then in the end I have 2 beepers on the middle point, and then I come back and select 1 beeper.
There should be like a thing where Karel can count the number of boxes there are, and then like for the
No, but Karel is stupid.
Yeah.
Karel cannot count.
It would be so easy if you could count, because then like for the checkerboard thing, if it had an odd number, then it would have like a different program than an even number.
In next section we have real Java that you can count. But here,
Can you make a protective void that makes Karel count boxes?
Oh my god, that would be amazing.
how do you do that?
I don't know.
Well, you can invent one. If you actually try to invent one, that's another assignment. You can think about it by yourself. Then how can you make a provided void that give the Karel the capacity to count?
To count.
Okay, so
Oh yeah, you can use beepers.
anybody think about another solution other than this?
Oh wait, I know how you can make them count. You can have them put a beeper in every box, and then put all the beepers in a pile.
And then count the beeper. Wait, what?
Like, how can I count?
Yeah, you can't. That's the worst thing ever.
Well, how do you utilize that number in this case?
You don't.
Okay,
Karel.
so is this the solution you all implemented?
I did.
Okay, so let's go with it. And
Too bad you can't count.
and then midpoint Karel.
Command count.
So the hint actually contains 3 steps. We can say private void run. So this is the entry point of the whole thing. And then remember this, all this thing is about decomposition from higher level to lower level. The hint contains 3 steps. The first is that put 1 beeper at the east and west end of the bottom line. So we can see the first line is that put beepers at ends. So we pretend that we already have this method that does the first step.
You don't put it in private void. It's public void.
That's a good catch. And then the second line is that we move them closer 1 step at a time.
So move the 2 beepers closer.
Move beepers closer. And then Well, after this, I need to clean up. So that's how I will do it using this hint. Now, how do I do the first one seems to be straightforward, right?
Yeah, you put beeper, move to wall, and then put beeper. Yeah.
Okay, so still, we want to make sure that we specify the precondition and postcondition. That's a good practice.
Okay, precondition.
So this is put the at ends. So what's the precondition?
That Karel is facing east at the
starting.
Karel starting from
1-1.
Yeah.
1-1 facing east.
With no beepers whatsoever in the world.
Yeah, well, you can say that. And then post.
There is a beep, 2 beepers, 1 at each end of the street. 1
beepers at 1 and
no, 1
1
at each.
and
Yeah, so 5, 2, 2, 4. No, each end of the street. Oh, the street is not 3D.
with.
Oh, you can't go with the beeper. This guy.
Okay. And do we need to worry about the position of Karel?
He is.
So the reason I'm saying that is that remember that we need, when you move Karel closer, the condition I made the suggestion here is that there is no empty space between them. So you can see that each time of the way that Karel is always somewhere in the empty space between those 2 beepers. So this is actually what makes it simpler in this case, where you can easily judge whether you finished moving them closer or not by judging whether there is empty space in there.
If no beeper is present.
Okay, so basically that means that here, to have a good start, we need to have Karel at the empty space between these 2 people. So now we can actually do this. What's the first step?
Put beeper.
And
Move to end.
move
to wall.
wall.
Put beeper.
Oh, which means that I need to extend superpower. Move to wall and
then put beeper.
Oh, it's easy. Then move back. Move back.
You don't have
move back. Do we have to move back?
No.
No. Now what should we do?
We stay there.
What? You mean we stay here like this?
Yeah, put beeper to end. And
Okay.
then when you move them closer, you can just pick that beeper up.
So which means that this doesn't hold anymore. You're standing at the beeper. Okay, we can try that.
So that way, when you do move 2 beepers closer, you can just pick up the beeper, and then move backwards, and then put the beeper.
Okay, so private void move beeper closer. And then what's the precondition?
That Karel is standing at the beeper standing on the beeper at the The last avenue?
We have beepers at east and west end of the bottom line, and Karel standing on the west end beeper. What's the post condition? What's the post condition?
So this one's for Karel. The beepers are next to each other, or there's just one beeper.
No.
Okay, let's see what we got. Okay, so let's see. So
you pick beeper because you're on a beeper.
Pick beeper. So which means that for this to work, this needs to have a post condition that Karel standing at
the westmost.
Right? Because, or else you cannot pick beeper. You're making the assumption there is a beeper here. So for this to hold, for this assumption to hold, you must have a post condition that guarantees this is true. So you put the beeper, and then what's next? Pick beeper, and then
you turn around or move backwards.
Turn around, and
then, well, this is what I put. While no beeper's present,
what's next?
You would move,
And
then you would put the beeper down. Then you would move again. And then now you have to check while no beeper's present again. Inside.
And
then if front is clear, move.
like that.
Yeah. And then else, turn around.
And can you explain your code here? So basically, now you're at the west end of this beeper, and you pick the west end up and turn around. You're facing wait. This is we're at the east end of the beeper, and then you turn around, and then now you're facing west. And then while no beeper is present, which means that you're moving towards the middle. So you take one step towards the middle, and then put down the beeper, which means that you already moved the
beeper one step closer.
Beeper one step closer. And this is the beeper on the east end. And then you move, and then you
so that way you can check if no beeper is present again, because if you don't move, you would be on a beeper, and then they would skip that loop and then go to the next thing.
And you basically want to move to reach the other beeper. You want to reach the other beeper, and then you don't want to hit the wall, so that's why you put the condition here. And then else turn around. This is a very interesting solution. So basically what you're doing is that here while entering this loop, you assume that you're holding a beeper here. So Karel is holding a beeper. And then you move, and then you put beeper down, which means that you make one move, and then you just put the beeper down, and then you go ahead and move. Is this move necessary then?
Which one?
This move. Why this move?
Because you're on a beeper, so while no beeper is present, there is a beeper present, so you can't do anything in that.
Okay, so you basically here you put down the beeper, and then you move to the next empty position, and then you try to find this loop allows you to try to find the next beeper in front of you, and then when this loop is finished, now you are standing on top of a beeper. You're standing on top of a beeper, and then you go back to while no beeper is present, and then you move. You see, I actually sense a problem here. This is my question to you. So, while no beeper is here, you put down the beeper, and then you move. And in this loop, you try to find your next beeper in front of you. And while you actually exit this while loop, there is a beeper underneath you. So you're standing on top of that beeper. And then you go to the top of the thing. This condition doesn't hold anymore because you're standing right at the beeper. And then you exit.
Yeah, so then afterwards you have to put something else. So
you're saying that here we still have some code to do?
Yeah.
Okay, so what do I do here?
Pick beeper and turn around.
Pick beeper. And then turn around.
It's still in the while loop.
Okay, there was two while loop. Which one?
The bigger one.
Oh, you're inside the bigger loop. Okay.
Yeah.
So let's reason about this.
Because there's a pick beeper and turn around before the while loop, so you fill it in at the bottom.
Okay, so let's reason about it. At this stage, well, we didn't change this part, so this reasoning still holds. At the end of this loop, which means that this loop condition right here, this condition doesn't hold anymore. So at this point, we're standing on top of a beeper. And then now we pick beeper. We can do that because we know we're standing on top of a beeper. And then we turn around.
And then you go back to the while loop.
And then you go back to the while loop, which means that Karel is holding a beeper. And so actually here is that Karel just picked up a beeper. That's a more accurate description. Karel just picked up a beeper, and then it moved and put beeper, which means that it tried to move the beeper one step closer.
The problem with this program that I came up with, it lands you with two beepers right in the center.
Okay.
Instead of two right next to each other. But it still works.
So
if there are two beepers, pick one.
No, as long as there are beepers, just because I know it's always.
So when does this thing actually end? So this program exit when this condition is no longer true, right? Oh, I'm sorry, this method exit when this condition is not true. So each iteration you try to pick a beeper here and then move it closer here. And then what we can see that when two beeper getting closer and closer, you put beeper down and you move, you actually step on another beeper. When two beepers are getting closer and closer, you reach to the point that two beepers are right next to each other. At this point, when you put the beeper down, right next to the other one, you make a move, and then in this condition right here, you're actually standing on top of another beeper.
So it stops the method.
So this one doesn't hold anymore. This check will fail, which means that it won't execute this loop. And then we're standing at here. So we pick beeper, turn around, and then we go back to this loop right here. This is still true because you just pick up the beeper. And then you move, and then you put beeper, which means that you're stacking two beepers on top of each other. And then you make another move. And then while no beeper is present, which is true, and front is clear, move.
I'm basically skipping the cleanup part.
So what I'm saying is that in this step, you are actually stacking the two on top of each other. And then you move away. And then when no beeper is present, you go forward and you'll hit a wall somewhere. And then you'll hit the wall and then you'll turn around and go back until you find the beeper who are actually stacked on top of each other. So you're standing on top of the beeper, two beepers.
Yes.
And then you pick one, pick up one, turn around.
Oh, because you can't check if they're two beepers.
And then this is actually not true anymore. So you exit.
It works. I just came up with it because it worked.
Okay, that's actually a very good solution. I just realized it will work. So.
But you have to delete the cleanup part in the public void.
So we don't need the cleanup anymore, right? Well, there is another way. If you do think that we don't need to actually, we don't need the cleanup, which means that we don't do anything here. So we can have an empty method that doesn't do anything. But you're stacking two beeper on top of each other when you exit, and you pick up one and turn around, and this thing is no longer true. You exit, which means that there is still a beeper on the ground.
Yeah, in the middle.
In the middle, and you still need to pick it up, right?
No, you have to leave. You still leave a middle point there, right?
Let's see the requirements. So basically, that's assignment
because you
1.
have to leave a beeper there to show that you got to the middle point.
So again, let's see the requirement. Go back to the specification. This is assignment 1, and let's find the.
Because if you pick it up, then there's no point, and all the beepers are gone.
You're absolutely right. There is one beeper right now set. So basically, in the requirement set that there is a beeper underneath you. Okay, in that case, you're right. We don't need to do anything. So let's run to see whether that works or not.
You have to delete the pick beeper part, or else it's going to be all gone.
Absolutely.
I like the cleanup too.
have to, because he has it in public void, and then there would be an idea issue thing.
So in this case, we have nine positions in the bottom, and let's see how it works.
Yeah.
So it tries to pick up beeper and put them closer, and then just as predicted, it works. And so this is Sophia's solution about move beeper closer. And what's yours? Other solutions? So how do you solve this? I guess this put beeper at both ends, it seems to be pretty easy, and the cleanup seems to be not hard at all, and all the meat is actually in the middle. So this is Sophia's solution, and it works. And two of you, why don't you tell me your solution a little bit? Anna?
Why am I first?
You can actually just read your program and see what's inside.
So you can just like while the beepers are at both ends, move just.
Excuse me, just a second. Well, what?
Okay, so like this is after put beepers at ends. So you should be like at the beeper that's on the right side. So pick up that beeper.
So here you pick the beeper?
Yeah.
Right here?
No, like not at on that program.
Move beepers closer.
Yeah.
Okay, so yes, now you're actually on top of the beeper on the right hand side. Pick beeper.
Pick beeper.
And
Wait, so like while you're holding the beeper, you can just like carry the beeper around, right?
yes.
Oh,
yes.
so you don't have to do anything.
Mhm.
Okay. Then move to wall. Or no, wait, turn left and move to wall. Or wait.
Turn around, you
Turn
mean?
around. Just turn around.
Oh yeah.
And move to wall, which means that you are actually on the left hand side. And
Then you have to, when you pick the beeper and you have to move and then you turn it like before move to wall and after turn around.
oh, so you're saying
Because you have to move the beeper one step closer.
Sister was removed from her family. That's so weird. Anyway, move and then put beeper. And then
so this actually move it one step closer, and then
move to wall, pick beeper, turn around, move.
Yeah, but you're not always guaranteed that the second beeper is at the wall.
But it is.
Right now, but you have to continue the loop. And continue to move.
So then you can do it if no beepers present, then turn and then keep moving until you find the beeper.
okay, so basically you can actually have another program
Oh
called
god, okay.
could
Wait.
move to beeper, which means that, is that what you're saying? So basically you keep moving while no beeper present. Move? Is that what you're saying? So instead of move to wall, I could say move to beeper.
Beeper wall.
And now you're actually standing on the beeper, put it up, turn around and move, and then put beeper down. And how do you actually put a loop? Where do you start the loop?
Like around the whole move beepers closer.
Okay, so around this thing, while something here. Is that right? And what's your condition?
move it then and then separate. Then,
You don't have it on your program?
okay. There should be a while loop for like wall not completed where you can check if there's one beeper in the middle or not. But that's the case.
Okay, so we're out of the time today. So let me give you my solution. So basically here, remember that the hint here gave a condition that you can use. The use is that you don't have any empty space between. So basically here, you're standing at the empty space between them. Sophia didn't use this hint, but we can see how this works. And here is in the empty space. Here is stopped because there is no empty space anymore. So we can actually use a while loop which says that you're standing at the empty space. No beepers present. And then in this case, you need to actually make this standing at an empty space in between. And so for this post condition to work, you need to turn around here and then move so that you're standing on the empty space in between.
And you're off the beeper in the next.
And then here is that while no beeper is present, since you're actually at the empty space, you need to find your next beeper first. Move to beeper. Well, remember, there's a tricky part here. It's that move to beeper, we actually keep moving while there's no beeper present. What if we've hit the wall?
Wall front is clear and no beepers present.
Yes, there was actually we have two conditions here. Unfortunately, Karel doesn't know how to do that.
Oh my god.
So this is the case where we don't need to worry about the wall because remember where we are. We are at the middle of two beepers. So before we run into any walls, we must run into a beeper first. So we don't need to check here.
Never mind.
See, actually, this is a mind game that you always check for different kinds of conditions. That's how you play the game. So we move to beeper, and then we pick it up, turn around, and move and put beeper. So this put one beeper closer to the middle. And then we do this again to the other end, find the other beeper, pick it up, move, and put beeper. So this put the other one closer. And this will exit when no beeper present is false, which means that when you move, so we still move beeper. And then we need to make sure that when we actually here, we try to stay at the middle. So here we actually go to the left side and put beeper and move it right. And here we go to the right hand side and then turn around, move, put beeper, and then move forward. So hopefully this will actually go, let Karel goes to the middle. And we have
Control Shift F.
okay, so this will actually give us the end condition I'm looking for. Let's try to see whether this works. Oops. Sorry, I think I made a mistake. I didn't save this. I saved it. So my implementation is wrong. Let's see what's wrong with my implementation. So
you pick beeper and then you turn around and then you move. So you don't turn around.
yes, I don't turn around here. And then I will put beeper down. Put beeper down. And then I move to beeper. So we're starting at this position. And then we move to beeper, which picks this one up. Move deeper, pick beeper, turn around, move, and then beeper. So let's see. This is where it goes wrong. See, I made a mistake somewhere.
It's being a butt.
So move to beeper, and then pick beeper. Turn around.
There's something wrong with the program's right. It's something's wrong with the computer.
So see, actually, there's a problem. This is running in the background, so it prevented the.
Oh, that can prevent it, really?
That prevent the program from updating. So let's see whether we can actually fix this time. There's something wrong with my program. Let's find out what goes wrong. So actually, we can actually put the breakpoint here, run it, and then start the program, and then goes to debug, and we use our stepping tool to go here, and then we pick beeper, and then we turn around, move, put beeper, move to beeper. Oh, we need to move to the middle.
Oh, so you have to do a move right after put beeper.
Yes, we always have to stand in the middle ground. So here, we actually need to move. So standing at the place where you don't have anything underneath you is a key point in this. That's how this actually works. That's a critical observation needed for this thing to work. Okay, so we start. And then we see whether we can actually make it work. It looks like it works.
Yeah.
Okay, now we
Disable breakpoint and then
continue.
Carol, run, Carol, run.
The only little thing where it's like if beeper's already pressed the door, put it down.
What?
So we actually, I don't realize where the problem is. So that's where the problem is. Okay, so why don't we do this? Since it's already 8:40 and we're 10 minutes over time, so we can actually stop here and let's finish this next time. Okay?
What's our homework?
So your homework is
Watch lecture 4.
real Java. So we say bye bye, Karel, and then watch lecture 4 and 5.
Oh, 4 and 5.
4 and 5. Yes, those are actually pretty basic Java. And then we.
No, you know, we have a long weekend and maybe money.
Yes, I know. That's why this is not a lot actually.
Okay, that's good.
Finish the first line here. Program assignment, problem 2 and 3. And this problem 2 and 3 is
Ooh, bricks!
no, that's no problem number 1. I'm not asking you to implement that. 2 is
Oh, target! Target!
so you just have to draw a bunch of circles.
Wait, this is graphic?
Yes. This is
Oh, I've
correct.
done this since I was in 1st grade.
What?
Yeah, no, seriously, they had us draw circles. They're like forward 10, R2 10, forward.
See, this is actually should be easy. So 2 or 3 should be easy. And
Oh, I think I know how to do it.
and then if you
I
have
literally have a notebook. from when I was
if
in
you
1st grade.
have time, try 2. Actually, 2 is pretty simple too. You'll find that with the disposal of lecture 4 and lecture 5,
You can do Midpoint Carol with ease.
because you are allowed to count now. You can count the number of cells in the bottom line, and then you all of a sudden you can count now.
Count.
Okay,
Carol went to preschool.
class is dismissed.
Remember this?
Thank you for coming.